Hello and welcome back. This video will cover section 1.2, which is on solving equations, and we'll start with linear equations. So a linear equation in X is an equation that's of the form ax plus b is equal to 0. A and b are allowed to be any numbers, so we see that we have one term that has just one x in it, and a term without any x's will just be equal to 0. Now, a cannot be 0. If a were 0, then a times x would also be 0, and now my equation doesn't have any x's in it. So in order for this to be a truly linear equation, a shouldn't be 0. So for instance, we could have 4x plus 12 is equal to 0, and this will be an example of a linear equation. So when we are talking about solving an equation, what we're meaning is we're finding solutions. And a solution is just any value that we can plug into our equation that makes it true. So for instance, I would claim that -3 is a solution to this equation. Why? Because if I plug in -3 into here, I'll have 4 times -3 is -12. -12 plus 12 is in fact 0. So this equation is true when I plug in -3. And I've underlined all here. It could be the case that an equation has one solution. It could have more than one solution, or it could have no solutions. So it's important to make sure that you find all solutions. There may be more than one. The solution set is simply the set of all solutions. So for instance, it turns out that if you were to find all solutions, there's only the number -3. -3 is the only solution to this. So the set containing -3 is the solution set. So when we're finding solution sets, or just solutions to equations, equivalent equations are going to be very useful. Equivalence equations have the same solution set. So what we'll do is essentially we'll transform our equations from something complicated to something simple so that we can find the solutions. So the first property that will generate, or the first operation that will generate equivalent equations is simply simplifying. So if we're given an equation, 9x minus 3x is equal to 4 times x plus 2, we can simplify both sides or any side of the equation, and the solutions will remain the same. So if I simplify the left-hand side, I'll get 6x. If I say distribute on the right-hand side, 4x plus 8, the solutions to the first equation are the same as the solutions to the second equation, but the second equation is maybe a little bit simpler to work with, which is why we would simplify things. Next, we can add and subtract something from both sides of an equation, and it has to be the same thing from both sides of an equation. So for example, in something like this, I could take and subtract 4x from both sides of the equation. And why would I do this? Well, the 4x and the -4x, when I simplify, will cancel out. And this is, again, a much simpler equation that has the same solutions as the one above it, which has the same solutions as those that came before it. So if we were finding solutions to this top one, all we have to do is worry about the bottom one. Simplifying makes things simpler. So the next thing that we'll do is multiplying and dividing, again, by the same thing on both sides will preserve the solution set. So when I have 2x is equal to 8, I could divide both sides by 2 and get the equation x is equal to 4, but the solutions here are the same as the solutions here are the same as all the solutions of all of the equations that I had written down. The one thing that we're not allowed to do is multiply or divide by 0. Dividing by 0 is always a bad thing. Multiplying by 0 gives us a different solution set. We can see here that the solution set is just the number 4. 4 is the only solution here. If I multiply both sides by 0, 0 times x is 0, and 0 times 4 is 0. So the question is, what are the solutions to 0 is equal to 0? Anything you plug in will work. So all numbers, all numbers are solutions to this. So the solution set changed. I don't want to multiply by 0. It doesn't give you anything. The last thing to mention is purely aesthetic. If you switch the sides of an equation, the solution sets stay the same. X is equal to 4 is the same thing as 4 is equal to x. So let's use these techniques to solve this equation. The first thing I'll do that I like to do is get all of my x's on one side of the equation and everything without an x on the other side. So we have the 4x there, but we also have a 5. So I will subtract a 5 from both sides of the equation. Simplifying, I get 4x, cancel. These guys will simplify to 24. And now I've got a 4x. I want to get the x by itself. So divide both sides by 4, and I'll get x is equal to 6. This is much simpler than dealing with the original equation. I can see the solution here. I couldn't see the solution up there. But gotta check. So let's check this. Let's plug in 6. 4 times 6 plus 5. Is it equal to 29? Yes. 4 times 6 is 24. And if I add the 5, I still get 29. So, yes, I get a true equation. Solving linear equations in general, they give us some nice steps. So again, simplifying both sides. Simplifying makes everything simpler. It's in the name. The next order of business is to collect terms of the variable. Say, collect all the x's and put them on one side, and everything without an x on the other, or whatever variable name we're using, y, t, it doesn't matter. We will try to isolate that variable. So up here, we had 4x is equal to 24. I didn't want the 4 there, so I divided both sides by 4. So we got rid of that coefficient, and then we solved. And then the last thing that you should always do is check your answers. If you don't know if you've done it right, check. And this will be better than plugging it into the computer and having it check for you and telling you that you got it wrong. So let's solve this and check. First order of business, simplifying. Let's distribute the 4 on the left-hand side. So we've got 4 times 2x is 8x. 4 times 1 is 4. Let's also distribute on this side. So we've got 29 plus 3 times 2x is 6x. 3 times negative 5 will be negative 15. We've got a little bit more simplifying to do on the right-hand side. So 25 minus 15 will be 14. And we still have that 6x. Next, I've got a 6x on this side. So what I want to do is subtract 6x from both sides. But I also have that 4 there, so I want to subtract 4 on both sides. Notice, the negative 4 I've put on both sides, and the negative 6x I've put on both sides. Whatever you do to one side, you have to do to the other. Next, simplify again. The reason that we put the negative 4 on both sides is so that those cancel. The reason I put the negative 6 on both sides is that these guys cancel. What's left? 8x minus 6x, that's 2x. 14 minus 4 is 10. Divide both sides by 2 to get x is equal to 5. Again, check. I can plug this back in. 4 times 2 times 5 plus 1. is it equal to 29 plus 3 times 2 times 5 minus 5? Start simplifying and check. 2 times 5 is 10, plus 1 is 11. 29 plus 2 times 5 is 10, minus 5 is 5. On the left-hand side, 4 times 11 is 44. 29 plus 15. Oh, it all looks good. 44 is in fact equal to 44. 5 is the correct answer. So the solution set is just the number 5. It's the only solution to this. The last thing we'll do is we'll look at an equation with fractions in it. Because I don't particularly like fractions, I want to get rid of them as soon as possible. So the trick is to multiply by the lowest common denominator of every single fraction. So we'll need to find the lowest common denominator, where the denominators are 4, 14, and 7. So the factors of 4 are 2 and 2. The factors of 4 are 2 and 7. And the factors of 7 is just 7. 7 is a prime number. So we need at least 2 2's and 1 7. 2 times 2 times 7 is in fact 28. So my trick will be multiply everything by 28. Whatever you do to one side, you have to do to the other. So let's multiply the left-hand side by 28 and the right-hand side by 28. So we've got our fraction here. I can cancel 4 out with the 28. We'll be left with 7 though. This will be 7 times x minus 3. I need to distribute the 28 on this side. So 28 times 5/14 minus 28 times x plus 5 over 7. So far so good. I can distribute the 7 to get 7x minus 21. Okay, so the left-hand side, that's as simple as I can make it. This fraction, I can cancel 14 out and be left with 2. And 2 times 5 is 10. Minus, I can cancel 7 out of here and be left with 4. So 4 times x plus 5. Furthermore, again, the left-hand side, I'm not going to do anything with for a moment. We're just going to simplify for now. 10 minus 4x, distributing that negative 4, minus 4 times 5, minus 20. And if I simplify that right-hand side again, 10 and minus 20 is minus 10, with that minus 4 hanging around. With all these minus signs, it's easy to get one mixed up somewhere. Be careful. The last order of business, get all of the x's on one side and get all of the constant terms on the other. So I've got a 21 here, in fact a negative 21. So to cancel that out, I'm going to add 21 to both sides. And I'm just going to simplify this for now. So I'll have 7x will be equal to minus 4x. Negative 10 plus 21 is 11. Lastly, I've got this minus 4x, so let's add a 4x to both sides. Again, minus 4x and 4x will cancel, so I'm left with 11. On the other side, I have 11. And lo and behold, the answer is 1 after I divide both sides by 11.